Number 1 reads, a ball is thrown horizontally from a cliff at a speed of 5 meters per second. What is its speed 1 second later? Okay? So not a hard problem, but a little tricky because you have to actually understand what the problem's asking. So step 1 is make a little what? Little sketch, okay? So all it is you're standing on a cliff. You throw a ball off the cliff. And in this case, they don't tell you an angle, so it's just thrown straight horizontally, which is good. You don't have to use any trig. The ball flies through the air, and then 1 second later, we want to know, well, how fast is it going? Okay? On our diagram, let's go ahead and label all the info. And the diagram is important because it really helps you visualize what's what in terms of which number is which piece of information. The first thing that's given is that let's go back up here, that it's going at 5 meters per second, and then time is 1 second later. Okay? So the horizontal velocity, that's important, is 5 meters per second. Okay? So again, the picture helps you visualize what the situation is, and then what numbers are which variable. Okay? And the question is, we want to know the speed here 1 second later. So the time is 1 second, but the speed, here's the tricky part. Okay? What you have to realize is when the ball is being thrown sideways, it continues to move sideways at 5 meters per second, but at the same time, it's also going to do what? Besides moving sideways in the x direction, who's going to pull on it in the y direction? Gravity. It's going to be in free fall, right? So it has velocity in the x, but it also has velocity in the y direction. Okay? And in fact, what we're trying to find is the VYF, the V final, right there. Okay? In order to get your final answer, you have to realize this is a right triangle. Okay? If we turn this into a parallelogram, or a rectangle here, your resultant is where you start to where you end up. This is the final speed right here. This is my V total for my final speed. So in other words, this is a right angle. If I know the x component is 5, if I can find this y component, a squared plus b squared will give me the hypotenuse, c squared. Okay? So it's not a hard problem in terms of the math. It's just tricky to realize that when you throw a ball off a cliff, it's going in 2 directions. It's going sideways, and it's going down vertically. So to get the total speed, that's what we're trying to find, the velocity total, or the speed total, we need to get the hypotenuse. Okay? So now we're ready to move on to step 2. Step 2 is to list all your info. What's the secret? Break it into how many columns? Into 2 columns. Okay? We know velocity x is 5 meters per second. We don't know delta x, but we don't really need to find it. We know time is 1 second. Vertically, how many knowns and unknowns are there? There are 5, right? We got VI, VF, A, delta y, and time. Okay? VI we can figure out because what's the initial vertical velocity? Is this ball thrown up or down? No, it's not. So it's a 0. Okay? VF is what we're trying to find. Okay? This VF is this VY final. Your book likes to call it VY final. I like to drop out the y's just because I find it cumbersome, but some people find that less confusing. So if you want to keep the y's in, that's cool. It's the idea that's important, not the labels. Okay? Acceleration due to gravity is what, everybody, on Earth? Negative 9.8 meters per second squared. Delta y we don't know, but we're really not trying to find it. We don't really care how far down it falls. And then time is 1 second. Okay? So you can see how by doing the 4-step process, we organize the information and then we zero in on what we really need to know. Okay? So in this case, we're trying to find VF. We know VI is 0. We know A is negative 9.8. We know time. So if we look in our nifty equation toolbox, which equation will be perfect to use to find VF? If I know VI, I know A and T. Equation number 1 is perfect. Okay? So by breaking down all the knowns and unknowns, it's really easy to know which equations to pick. So in step 3, we first solve in the vertical direction. VF equals VI plus AT, because we want to know that final speed vertically to get our total velocity here. Okay? So VF is simply equal to 0 plus negative 9.8 times time. This one we don't really need a calculator. The final vertical speed is negative 9.8 meters per second. In other words, after 1 second, the ball will fall and speed up to negative 9.8 meters per second. Okay? If this is the y component, negative 9.8 right here, and I know the x component is 5, I can get my total speed, my v total, because that's a right triangle, right? This is a right angle. A squared plus b squared is c squared. In other words, the total speed is the square root of the x speed squared plus the y speed squared, right? The Pythagorean theorem. So in other words, if I just simply take the square root of my x speed, which is 5 squared, plus my y speed, 9.8, don't really need to worry about the negatives because it's square root value of a squared. I'll get my final speed, okay? So watch out for order of operations. I'm going to do the square root of 5 squared plus 9.8 squared. Put that in parentheses, okay? And I get my final answer of like 11.00 in this case, okay? If I do whatever, I'll keep 3 sig figs, 11.0 meters per second. So in other words, my final total speed depends on how fast I threw the ball sideways, 5 meters per second, and then how fast it ended up moving in the vertical direction. And in a nutshell, that's number 1.